Hi everybody, this is our video on product and quotient rule. So if you remember, one of the ways that you know how to do the derivative, if you have cxvn, where c is just a constant, and you know the shortcut, which is just a constant goes along for the ride, you bring the exponent down, and then you take the exponent, subtract 1, and this is the derivative of your basic form of your function here. Now, realize that not every function is going to be this simple, just a constant, an exponent, and a base. There's many more complicated functions out there, and our goal is to find the derivative of all of those. So as you do this, make sure your video is not on mute, listen carefully, and write down all the examples. There's going to be some that I do out with you and some you tries. So far you know how to find derivatives, which is the same as an instantaneous rate of change or slope to a tangent line in this form right here, like I wrote over there. So again, the exponent does not have to be positive. It does not have to be an integer. We practiced with ones where you had like a radical and you wrote it as a fractional exponent, or whenever we had a denominator and you rewrote it without the denominator by making the exponent negative, and we could still find derivatives in this form with the basic rule. Now we're going to use the product and quotient rules to find even more types of derivatives. So let's start with the product rule here. Now when you hear the word product in math, you should think multiplications, specifically multiplying two functions together for now. You could probably do this for the three functions, but we're only ever going to be doing this for two functions multiplied together. So notice in each of these, we have a first function and a second function. They're color-coded so you can see the difference. Now, what I want you to realize is in this function right here, you might be thinking, well, why do I have to use the product rule? Because can't I just FOIL this thing out and get something like 5x to the fifth, and then 7x to the fourth, and x cubed, and then you could keep FOILing this thing out, and then you would just have 6 terms, and you could technically do the derivative of each term one by one, like this. But you know, whenever there's a ton of FOILing that you have to do, it's just a lot easier to do product rule. We'll see why as we do more examples. Also notice that in these two examples here, we cannot FOIL, because I have a radical times a trig function, and then I have a binomial, 2 terms times a radical. So in these two cases, you would have to do product rule. There wouldn't be any easy way out with the basic rule up here. So we're going to do product rule for an example together here. So make sure you have all this written down. Pause if you need to. All right, so here is the product rule. Put a big box around this so you can refer to it. You'll be doing this so much that you'll have it memorized in no time. If I have a function f times g, the derivative is not, now this is very important because I have people that like to do this. You don't just say, oh, the derivative of the first times the derivative of the second. That's very, very, very bad. Don't do that. There's a specific rule you have to follow. You could do f times g prime plus f prime times g, where these are derivatives, and these are just the regular functions. F is what I'm calling your first function, and g is what I'm calling the second function. You don't have to use f and g, but in most books they will be using that. Now because this is multiplication here, multiplication is commutative. So instead of doing f then g prime and then f prime g, you could do f prime g and then f g prime. Order is not going to matter only in this case because addition is commutative and so is multiplication. So let's go ahead and do an example out. What I want you to notice is each part, so the f and the g, has its turn to be the derivative while the other is waiting its turn. So here g is the derivative, f is waiting. Now f is the derivative while g is just waiting. So let's do this example right here. Here's our regular function, and I want the derivative of it. Now I'm not going to FOIL it out. I'm going to use the product rule. Before I go ahead and do that, I just want to rewrite it one more time, and I'm going to go ahead and get rid of that denominator right here, just because it's always a lot easier to do derivatives when there's no denominators and no radicals. So now that I'm doing a derivative, I'm going to label it as f prime, not f. And let's go ahead and use the rule. So here's the first, and here's the second. So I'm going to go ahead and do first So x cubed plus 7. I'm not touching it. Oh, just realize that in this case, this is what I'm going to call f, and this is what I'm going to call g. Okay, so anyway, I did f, and now I'm going to multiply by g prime. So that would be 2 times 1/3 x to the negative 2/3 plus negative 1 x to the negative 2. And then I'm going to add. Now I have to do the derivative of the first, so it's now this guy's turn to be a derivative. 3x squared, derivative of 7, 0. And then I'm not going to touch this. X to the negative 1. Just color-coded everything so you can keep f and g apart. What you always want to do is clean things up. So I'm going to rewrite this again. Things like 2 times 1/3, you really should just make that 2/3. Now here I generally try to avoid negative exponents. So to make that positive, I'm going to put it in the denominator. And plus a negative, just make that minus. So I took care of that. And then I have x to the negative 2, that's 1 over x squared, plus 3x squared, and then this. Now I'm not going to simplify anymore for now. We will be practicing simplifying more, where you would actually FOIL things out. That can get a little more complicated. For now, I just want to focus on the actual rule here. So I'm going to give you 2 to try and make sure this is all written down. Pause the video and go ahead and write these down and try the rule. If you mess up, you can always just watch afterwards and fix any mistakes. So make sure you're trying these on your own. All right, so here are the 2 examples done out and color-coded for you. Notice that I rewrote any denominators as a negative exponent. I wrote my radical as a fractional exponent. Did the same here, cube root, I wrote it as 1/3. So check your work. You should have final answers here and here. If there's any mistakes, please fix them so you're not keeping wrong work in your notes. If there's any questions that you have that you're not sure of when you look at the work, just let me know in class tomorrow and we can talk about them. Okay, time for the quotient rule. Quotient rule, when you hear quotient, you probably think division in math. And quotient rule you are going to use when you have 2 different functions that are divided by one another. So you're going to have a numerator and you're going to have a denominator. Now we're going to talk about ways that you can avoid the quotient rule and use the product rule instead. So start thinking about that. You can always use a quotient rule, but some people like to avoid it sometimes and use product rule, so just keep that in mind. So only whenever you have 2 functions divided. Now, when you do quotient rule, so for example, you would not say, I'm going to cross this out in a second, you would not just say, oh, the derivative of the top is 1, and the derivative of the bottom is 3x squared. That's not what you do at all. Just like with the product rule, there's a certain rule you have to follow. So put a box around this. This is the quotient rule. And it's a little bit more complicated than the product rule, but not really. What I want you to do is look at the numerator here really carefully. And then look here. You should see that the product rule and the quotient rule are very, very similar. The main difference is for the quotient rule, we are subtracting. That's a subtraction sign right there. And because for subtraction, order matters, f prime has to come first. You start with the derivative of the top, the regular denominator. Then you subtract the numerator times the derivative of the denominator all over your denominator squared. This is what I was saying up here. Can't just divide by the derivative of numerator divided by derivative of denominator. You have to follow the rule. Okay, so another way of viewing the quotient rule is like this. You can call G the bottom. You can call F the top. Another way of doing this, which is actually how I learned it whenever I was in high school back in the day, my teacher, instead of saying f of x over g of x, she called the top function high because it's up high. She called the bottom function ho because it's down low. And then she followed this. And to help you remember this, I found this absolutely incredible song on YouTube that you're going to love. Check this out. Seriously. probably enough for that. I think you get the idea. In case you're wondering, they're going on tour this year. Also saying Get Down on It. Great band. YouTube's great, isn't it? The stuff you find on it. So right here, this rule is ho-de high minus high-de ho all over ho-ho. Main difference to remember here is you always start with the denominator times the derivative of the top. So every time I do quotient rule, I'm always thinking in my head, ho-de high minus high-de ho all over ho-ho. If you don't like that way, then just memorize the rule. So I'm going to do one example with you here, and then I'll give you two to try, and then we'll be done. So I rewrote the quotient rule right here for our reference, and let's try it out. So I want the derivative of g, d dx of g. Now, you do not have to write it like this first. All that this is emphasizing is that we're going to do the derivative of the top times the bottom minus the top times the derivative of the bottom. d dx means, hey, do the derivative of this. But you can skip that and go right to here, and let's go ahead and do it. So I have ho-de high, so I'm going to start with the bottom. D high, the derivative of the one on top, so I have 4 times negative 3x to the negative 4. Derivative of 2 is 0. Minus, down without doing anything to it, just the regular numerator. D ho, so the derivative of the bottom, so that's 5x squared minus 9x. So take a look at that and make sure you're okay with everything that just happened here. So I have ho-de high minus high-de ho all over ho-ho. So the denominator squared. So I'm not going to do anything to the denominator. I'm just going to write it and square it. So let's clean this up a little bit here. What I did here was multiply these two, put this in the denominator, put that in the denominator. Here, here, and here. So go ahead and finish copying that down, and you're going to try 2 on your own, and we'll see how you do. So we have example 1 and 2 here. What I would recommend is I would rewrite this without a radical, so that'd be x to the 3/2. I would write this without a radical, and this right here is 8x to the 1/2. That 1/2 doesn't really look like an exponent, but it is. So no radicals, always write them as exponents. It makes it a lot easier. So go ahead and try the quotient rule on these, find the derivative, clean them up, and then check your work. Make sure you pause the video now so you can have time to try it on your own. All right, check your work here. Hopefully you have something close to what I have. If not, identify what your main issue was and fix it, so that when we practice it in class, you'll be good to go. It should be blue. All right, so this is the product and the quotient rule along with, now you know 2 rules in this video. You also know the basic rules. So you have 3 derivative rules here. We're just going to keep adding more and more on. Make sure you know the rules, you're comfortable with them for any quizzes coming up, and I'll see you later.